Hey everyone, so today I will be telling you about weight and terminal velocity. So first of all, what is the difference between weight and mass? People do tend to confuse them. So I have this exercise in here, this animation from BoardWorks, and I cannot tell you to pause the video, but you can think about it as the sentences come by. So the effect of gravity on an object. So this is definitely to do with the force of gravity, and weight is a force, so it needs to be weight. The amount of matter in an object. So this is the stuff that things are made of. That's about mass. Measured in newtons. Well, forces are measured in newtons, and weight is a force, so it must be weight. Always the same. So because the effect of gravity on an object changes the weight of the object, the weight of the object is different in different places, but the mass, because it's always the same amount of matter that is in the object, is always the same. Varies on different planets, so that's going to be the weight, and measured in kilograms, that's the units for mass, so that's going to be the mass, okay? So mass is something that is the same, is always the same, and you can think about same as an S, A, M, and then an E in there, okay? So it's the amount of stuff something is made of, and because it's the amount of stuff something is made of, doesn't change anytime, and is measured in kilograms. Weight is a force, so weight varies, wobbles, okay, changes. And the weight is the effect of gravity on an object, is a force of gravity. Weight and force of gravity is the same, is measured in newtons, and because it's to do with the force of gravity, changes according to the planet where you are in, okay? All right, how do I convert from mass, weight, or weight to mass? So weight, W, or as I put here, Fg, force of gravity, equals the mass times the gravity. And this G is the gravitational field strength of the place where you are. So because weight is mass times gravity, mass, if you rearrange the formula, I don't know why my G disappeared. Mass is going to be the force of gravity over the over the G, the gravitational field strength, okay? So Fg stands for weight and is coming in newtons. M is the standing for mass and comes in kilograms, and G is the gravitational field strength, something that changes according to the place where you are and comes in newtons per kilogram. Now on Earth, G is 9.81. And that is what you should be using really for exercises. But imagine that you don't have a calculator in one day or any of these things. You can just make it as 10, okay? It just makes life easier. But if you can, use 9.81 because that's really closer to the real value, okay? So now, I have here an exercise, and I have a footage of an astronaut jumping on the moon, and you're going to see why I'm showing that. So the moon has about 30% of the gravity on the Earth, so obviously it does not attract the body towards its center as fast or as strongly as the Earth does, and you will see that the astronaut seems to be jumping in slow motion, okay? And this is because of the gravity of the moon, which is lower than the gravity on the Earth. Now, quick exercises. Calculate the weight of a steel bar of mass 20 kilograms. So, do I have the answers? No. I'm going to use 10 as the gravitational field strength, just because I do not have a calculator here. So I want the weight. Weight is mass times gravity, so it's 20 times 10. So that gives me 200 newtons. Calculate the mass of a person of 550 newtons. Again, mass is going to be the force of gravity over G, the gravitational field strength. Assuming that G is 10, it gives me 55 because it's 550 over 10. Gives me 55, and the units are kilograms. The gravitational field strength at the surface of the Earth is 10 newtons per kilogram. For the moon is 1.6 newtons per kilogram. So, my 30% in there. So, calculate the weight of a person of mass 50 kilograms on the surface of the Earth. So again, let's make the Earth as 10, just make it easier. So the weight will be 50 times 10, so 500 newtons. And then on the surface of the moon. So again, I would do 50, but this time times 1.6, and this gives me 80 newtons, okay? So there you go, some exercises to do with weight and mass. Now, why does weight comes in the same lesson as terminal velocity? And why am I showing this exercise in here to do with resultant forces? This is because when you deal with terminal velocity, you think about, for example, an object falling down or someone jumping out of a parachute, and you need to know resultant forces well. So I have here this exercise first to ensure that we know about resultant forces well, so we can understand the physics of skydiving and terminal velocity. So I have 6 boxes, 3 of them are not moving, 3 of them are moving to the right. I want you to tell me what the boxes are moving or doing, if they're moving, not where they are. So pause the video if you want to try. Otherwise, here come the answers. So first one, 5 newtons and 5 newtons. The forces are balanced, resultant force is 0, so the box is not moving, okay, stationary. Second one, 5 and 8, the forces are unbalanced, resultant force is 8 minus 5, so 3 newtons. Resultant force is to the left, and that's the direction that the box is going to move. Lastly, on the box not moving, 5 and 9, again, resultant force is different to 0, therefore the forces are unbalanced. Biggest force is the 9 newtons, 9 minus 5 is 4, so the box moves towards the right side with a force of 4 newtons. Now, imagine that my object is not stationary and it's moving instead. So 7 and 5, again, resultant force of 2 newtons, in the opposite direction to where the box is moving, so the box will decelerate. 5 and 10, resultant force is 5 newtons to the same direction to where the box is moving, so the box is going to accelerate. And finally, 5, the box has a resultant force of 0, forces are balanced, so the box keeps moving to the right at constant speeds. So, now that you know about the forces and what happens, click on this link on the video Physics of Skydiving and you will see the following. You will see an object trying to go, a person going on free fall, okay? So jumping out of an airplane, for example, and this is called free fall because no forces are acting on the person besides of gravity, so it's falling freely, okay? And what you will see is that all objects fall with the same acceleration independently of their mass. So it doesn't matter the mass of the object, the same object is going to fall equally fast or with the equal acceleration as they fall down, because the acceleration they fall is the same as the gravitational field strength or the gravitational pull of the planet. Meaning that if you have, as you saw in the first slide, a bowling ball and a feather, and you let them go at the same time, they will in fact fall at the same time. Now, if you really want to see this happening, you need to click on this video where Brian Cox is in going to go on a vacuum chamber, and this experiment is done in a vacuum. In a vacuum, we guarantee that the only forces acting on the ball and the feather are the force of gravity. And the force of gravity is the same because they are in the same planet. So you will see, in fact, the ball and the feather falling exactly at the same time. Now, in everyday life, the ball would fall faster than the feather, and this is because of the air resistance, okay? So the air resistance would decelerate the feather much more than the bowling ball, and that's why you don't see them happening at the same time. All right, and this all has to do with this motion or this terminal velocity that you already saw if you saw this video of skydiving. So what happens? And here's the video again if you want to watch it. So what happens? First, you get an object that is released, and the only force on the object is going to be the force of gravity. So the object is going to have a resultant force that is different to 0, and is going to move in the direction of that force. And because the object was in fact moving already, then it accelerates in the direction of the force, okay? Now, what happens is, as you have the weight of the object first, the only force, as the object is falling down, it's going to feel a drag force because it's going to fall through the air or through a liquid. So the acceleration of the object is going to decrease as it falls because the drag force, friction, air resistance, water resistance, whatever the drag force is, force is going to increase as the object speeds up, because as the object speeds up, it encounters more particles per second, so more particles trying to slow it down. So you get an object, it starts to fall due to the force of gravity, but it starts to decelerate as it falls due to the force of gravity and being balanced or starting to be balanced with the drag. Now the resultant force, which would be the force of gravity or the weight minus the drag force, is going to decrease as the object falls, because the drag force is going to increase the faster the object falls, and therefore, because the resultant force decreases, acceleration also decreases. Remember, force equals mass times acceleration. If my resultant force gets smaller, my acceleration gets smaller. Alright, so I start moving, I only have the weight, and then because I'm moving and passing through a substance, air for example, I get more and more air resistance. My resultant force starts to decrease. This makes my acceleration to decrease, okay? Alright, what happens after? Well, eventually the drag force and the weight are going to balance each other. Now, if the forces balance each other, resultant force is zero. And what do I have when I have resultant force of zero in an object that is moving? I have constant velocity. So that means that the object reaches a constant velocity, and this happens when the drag is equal and opposite to the weight. The resultant force is zero, therefore the acceleration is zero. This is known as terminal velocity, meaning the object cannot accelerate any further, is terminal. Just like you say a terminal disease, you know that a person is not going to live more than a certain number because the disease is terminal, so it makes an end to the person's life. The same with velocity. Because of the weight and the drag force that you have, and because these forces are now balanced, and you cannot ensure that the weight becomes bigger than the drag, then is a terminal velocity. You cannot go any further than that, okay? Do watch the two videos that I put in here. Well, there's also the astronaut, but they really make you understand this topic well, okay? And here it is if you want to take notes of the video. So they do of a skydiver falling through the ground. Initially the weight is bigger, so he accelerates, but as he accelerates towards the ground, drag increases. If the parachutist opens the parachute, drag increases very rapidly suddenly, because I have a large surface area from the parachute, so the parachutist decelerates very quickly. However, because he's going to decelerate and slow down, then my drag is going to decrease slowly, because I'm going to face less and less air particles per second. So I get a second terminal velocity, okay? And then finally, when it reaches the ground, the parachutist stops because the weight is counteracted by the force, the normal force or the reaction from the ground, okay? So that is a summary of what you would have seen in the video. I hope this math lesson made sense, and up to my next video, be happy and healthy. Bye!